All right, my secondary math 1 class. I know it has been a minute since we formally talked about inequalities and linear equations, but we are going to be continuing with that concept this week, okay? So, we know that inequalities are math sentences where they're not equal, right? So in number 1, it says that x, whatever x may be, could be any number, it has to be greater than or equal to -3. Okay, so in number 1, it is asking us to graph. It says draw a graph for each inequality. Okay, so we have, first of all, we need to decide at what number are we going to put our point. Okay, we're going to put our point at -3, right? So we know -3 is going to be right there. Okay, I almost pointed to +3. -3 is right there. So now, what kind of point are we going to put at -3? Is it going to be an open point or a closed point? Okay, hint, think that there's a little bit extra here. It has that line underneath. Okay, so we know it's going to be a closed point at -3. Okay, so now you can think of this in 2 ways. I've kind of explained to you guys the trick of having the sign point which way you want to shade as long as the variable comes first, right? In this case, the x is coming first. But you can also think of what it's actually saying, right? So this is saying x is greater than or equal to -3. Okay, so which numbers, is it on this side or that side, are greater than 3? Okay, where are they getting bigger? Okay, it'll be to the right, right? These numbers shading this way, those numbers are getting bigger, greater than -3. Okay, you also could have thought, oh, okay, my variable came first, so I know that that is pointing to the right. Okay, perfect. So now let's look at number 2. Okay, number 2. We have x is less than, or greater than, excuse me, x is greater than -4. So what point am I going to put on this number line, and what number am I going to put that kind of point? First, starting off, is this going to be an open or a closed point? It's going to be an open point, right? It is going to be an open point at -4. So -4 right there. Okay, so now you can think of it 2 ways. My variable came first, so you can turn that into an arrow. The arrow's pointing to the right, or you can say x is greater than, okay, bigger. Well, I know my numbers to the right are bigger than -4. Okay, beautiful. So that's when we're graphing when our variable is all by itself. Okay, so now let's look at number 3. So number 3, we cannot graph it quite yet because my variable is not all by itself. I still have this -18 attached to it. Okay, so what I'm going to do is I'm going to rewrite it down here. -36 is greater than or equal to n minus 18. Okay, I'm going to rewrite it because we actually have to solve it. We need to get n all by itself. We're going to solve this just like we'd solve any other equation. Okay, so we can draw our line down our inequality sign. Okay, I need to get rid of whatever's attached or on the same side as my variable. Okay, I have this -18 or -18 on the same side as my variable. So what is the opposite of -18 or -18? That is going to be +18. Okay, we got to do the opposite of it, but we also have to do the same thing to both sides. So whatever you do to this side, you must do to this side. Okay, so we add 18 right there. Okay, so now, what is -36 plus 18? You can always use a calculator. -36, we're in the negatives. We're moving towards the positives. We're going to end at -18. Okay, so -36 plus 18 gives me -18. Okay, on this side, all that's left is that n. Okay, copy down your sign, it's still greater than or equal to, and there we go. Okay, so now let's go ahead and graph it. Okay, so we have our point is going to be at negative 18, right? And what kind of point is it going to be? Okay, so we have a little extra, so we know it's going to be a closed point at negative 18. Okay, so is our arrow pointing to which direction we should shade? No, it's not. Okay, because our n actually came second, our negative 18 came first. So we can either flip it, okay, flip sides, and make sure you flip the sign as well. So that would turn n is still less than, the gator still wants to eat that negative 18, so n is less than or equal to negative 18. Okay, now that my variable came first, that we've flipped everything, okay, we can go ahead and look that our arrow is pointing to the left. Or in other words, n, or any number, is less than. Okay, my numbers are getting smaller, getting more and more negative, going to the left. So we know shading to the left. Beautiful. Okay, so remember on these guys, when your variable is not all by itself, you have something on the same side with it, you must solve it before you graph it. Okay, so let's look at number 4. Okay, number 4. So we have 4 is attached to that P is less than 56. So I'm going to go ahead and rewrite it down here so we can go ahead and solve. 4 times P is less than 56. Okay, so we're going to solve this the exact same way, right? We're trying to get that P all by itself. So you can go ahead and draw your line down your inequality sign. Okay, and we need to get rid of whatever is on the same side as our variable. Okay, so what's attached or on the same side as my variable is this times by 4. The 4 is right next to it, so we know that it is being multiplied. Okay, so what is the opposite of times by 4? That is divide by 4. So we are going to divide by 4 on both sides. That gets rid of that. Okay, my P is going to end up being all by itself. Okay, just copy down your inequality sign. And now we have 56 divided by 4. You can always use a calculator. In fact, I'm using one right now. 56 divided by 4. And I accidentally typed it in wrong. That is going to give me 14. Okay, now that my P, or my variable, is all by itself, now I can go ahead and graph it, and this one is awesome because my variable is coming first, which means that is pointing to the direction I'll shade. But first we got to decide what point or what number am I going to put a point at. Okay, that's going to be positive 14. And is this going to be an open or a closed point? It's going to be an open point. Okay, this is saying P is less than 14. Okay, the numbers that are less than 14 are 13, 12, 11, or you can say it's pointing to the left, shade to the left. And there we go. We solved it. We got P all by itself before we could graph it. Beautiful. Okay. Numbers 5 and 6. This is a new concept that we have not talked about. Okay, so notice we're not graphing inequalities. Okay, we're going back to equations. Okay, notice that the signs, these are not inequality signs. Okay, notice at the top of our paper we have inequalities and linear equations. Okay, that's because we have equal signs down here. Okay. So there's a few notes that I want us to write at the bottom of our paper. This is really going to help us graph these equations. Okay, so both of these equations are written in what's called slope-intercept form. And yes, you need to write this down. Slope-intercept form. Okay, this is probably my favorite form. Probably one of the easiest to graph. So now the actual format, you're gonna see a lot of letters here. That's okay. We will identify what these letters actually mean. Okay, so slope-intercept form is written like this. Y equals, okay, notice that both of your equations start with y equals. Okay, y equals. Okay, so it always starts with y equals. Then we have an mx plus b. Okay, a lot of letters there, but all we're doing is now we're going to identify what these letters actually represent. Okay, so the y and the x, these guys always stay the same. Okay, so the y and the x, they're always there. They always stay y and x. Okay, so those guys, you're always going to see a y and an x. So notice back on your equation, y equals, there's your x. Okay, y equals, there's your x. The only difference is instead of an m and a b, we have numbers now. Okay, so now let's identify what is the m and what is the b. Okay, so our m, that guy is our slope. Okay, so our m is our slope. Our b, that guy right there, that is our y-intercept. Okay, and notice slope-intercept form. Well, there's our slope, and there's our y-intercept. Okay, beautiful. So even if that's not quite making a ton of sense, that's okay. We are going to practice it. But now, let's go right next to our definition of our slope-intercept form. Let's write down our steps to graphing. Okay, steps to graphing. Okay, so our first step to graphing, number one, start with the y-intercept. That's like your starting point. Okay, so you're going to start with your y-intercept. Okay, then your second step, use the slope to count to your next point. Use the slope to count to your next point. Okay, beautiful. And the last little note we are going to write, let's write it over here on the other side. Last little note we're going to write is that slope is always rise over run. Okay, and we'll talk about that more in just a second. Okay, so make sure you have all of those notes at the bottom, and then we will go ahead and practice actually graphing these equations using all this stuff we just talked about. Okay, so let's look at number 5. Number 5, there we go. Let me zoom out just a little bit so we can see our steps. Okay, number 5. So the first thing I want us to do is identify what is our slope and what is our y-intercept. And yes, I do want you to write this on your paper. Okay, so looking at our slope-intercept form, okay, notice that your slope, your m, is always in front of your x. Okay, so looking back up at our first equation on number 5, what number or fraction, hint, is right in front of your x? That is going to be your slope. Our slope is -1/2. Okay, you must include that sign. Slope is -1/2. Okay, now the y-intercept is always the number that's hanging off the end of the equation. Okay, so what number is right at the end of the equation? It's going to be a +1. Okay, so now that we know both of those things, which our equation just simply told us, we can look at our steps So our first step to graphing is start with our y-intercept. Okay, so now our y-intercept is at +1. Okay, so notice here, y-intercept, there's your y-axis. Okay, your y-axis is always the one that's going straight up and down. Y-axis, this guy's your x-axis. So we want to put our point on our y-axis where it tells us to. Okay, where are we going to put that point? What number is that? That is a +1. So I'm going to put my first point right there, a +1, right on my y-axis. Okay, so we did number 1, check, start with your y-intercept, that's your starting point. Now, number 2, use slope to count to your next point. Okay, this is how we're going to count, so look over here. Slope is rise over run, which means you're always, you must rise before you run. You must always go up or down before you go left or right. Okay, so looking right here, our slope, our rise is -1. Okay, so from this guy, I'm going to go down 1. That's what that means, -1. So I'm going to go down 1. That's our rise. Now we can run. We're going to go over 2 from this point. So we went down 1. Now we can go over 1, 2. There's our next point. And we could go on and on. So down 1 again, 1, 2. Let's do it again, 1, 1, 2. Okay, and here's the great thing. We could also go backwards because these guys are linear equations, meaning they form straight lines on the graph. Okay, so we could even go backwards. You could go up 1 and backwards 2. Okay, still a straight line, up 1, backwards 2, up 1, backwards 2. And there we go. All you got to do now is connect those dots. Put arrows at both ends of your line because this line goes on forever. That's what that means. And it is graphed. Okay, that's all we got to do. We started with our y-intercept, which was at +1 right there. And then we used our slope to go down 1 and over 2. Okay, here's another note that I need you guys to write on your paper. Let's star it. When the slope is negative, the line goes down to the right. Down to the right. Okay, so if we're moving from left to right, we see that our line is going down. Okay, so that's an important note. Write that on your paper. Beautiful. Okay, our last example. Let's look at number 6. Okay, so we're going to do the same things. So first things we want to do is identify what is our slope and our y-intercept, because that's going to help us graph it. Okay, so again, your slope is always the number that's right in front of that x, right? The m is right in front of the x. So in number 6, what number is right in front of the x? We have +7. Okay? And what is our y-intercept? Our y-intercept is always the number that's right on the end of the equation. What is the number that is right on the end of the equation? We have -3. Remember, just because it is plus in the formula, if it's ever a negative, you must include that sign. It's -3. Okay, so let's go ahead and graph it. So using our steps, we always start with our y-intercept. So on your y-axis, the line going up and down, you are going to put your first point at the number it tells you, right? Your y-intercept, which in this case, we're going to put our first point at -3. That's right there. Okay, beautiful. Now, we need to use our slope to count to our next point. Okay, but you might think, well, Mrs. Campbell, slope is rise over run, and I only see a rise right here. Okay, remember that all whole numbers can also be written over 1. Okay, now we have our rise over our run. Okay, we must rise before we run. So from our starting point, let's rise 7. Okay, so from your starting point, 1, 2, 3, 4, 5, 6, 7. Okay, now we need to run 1. Okay. If we were to go backwards, we'd go off the graph. If we were to go up 7, we'd also go off the graph. So 2 points here is totally fine. So go ahead and connect these points with as straight a line as you can. Okay, put arrows in the end. And there we go. Okay, notice, is my slope positive or negative 7? It's positive 7. So last note I want you to write on your paper, when the slope is positive, right? In this case, it was a positive 7. The line goes up to the right. Okay, so notice on number 5, our slope went down and to the right. When it's positive, it is now going up and to the right. Okay, beautiful. So there are all our notes. They will be linked for you on Canvas if you missed anything.